So, welcome. My name is Luisa Raviol. I work as a sales engineer for MariaDB Corporation. I've been working with MariaDB for almost 9 years now. Prior to that, I was working as a project manager on projects based on open source databases, mostly related on database publishing. Then many years of coding, but those are gone. What will we cover today? I want to talk to you a little bit about what we see as MariaDB Corporation when we talk to our customers and prospects. We're seeing more and more the rise of what we call the hybrid workload. Why? Because most of our customers started or are mostly running on typical transactional workload. They have a typical transactional environment where they mostly work on current data. Their queries are normally focused on range of values, and what is probably the most important part, that they are running on known queries. So the relationship between the application and the database is well known. The database is supposed to get queries that are known, and the database administrator are normally required to fine-tune the database so the queries can run fast. So that's a little bit simplifying a little bit the scenario. On the analytical aspect, the situation is slightly different. We are talking, first of all, more data in terms of volume, but this is not exactly the main point. More data are now there, even the transactional environment. But we are referring mostly to more historical data. So even if the volume is big in either situation, the idea is that when we query data with the analytical purposes, we are not now talking more historical data back in the past, ranges of dates in the past. And what we are now normally required to do is to retrieve information that are based on aggregate queries. So we're normally required to calculate averages or numbers that are related to groups and aggregations. And a very important aspect is that on many of those applications, it's not granted that the queries are known. Sometimes you're working with tools or solutions that are providing the customer a front end or a graphical tool that put together queries that are not known in advance. So the database is actually there to receive any kind of query, and it has to be responsive. So no room for fine-tuning, no room to fine-tune the query or tune the database in order to support complex queries. So that's the scenario, and the scenario is based on the fact, most of the cases, that everything started with transactional workloads, where both analytical queries and transactional queries were run. And over the years, when the size of the data and the size of the dataset grew, and more users, the application became more and more popular, and more users were using it, and more data were stored, the range, the level of the performance started to decrease. So the performance of the analytical queries on the typical transactional environment at the beginning was good enough. So running transactional queries and analytical queries on the same database was anyway a good and acceptable way to run queries. The more we go in terms of size, in terms of users, in terms of data volumes, the less it is when it comes to run analytical queries. So the typical idea has been in the past to have a transactional environment, the OLTP typical environment, and data warehouses. So as soon as you see that you can't really cope with it or the workload of the analytical, you need to have something more ad hoc designed for that. And what's the main reason? Again, the different type of queries and the typical different use of the database, but also the fact that the two technologies are then designed to support the workload in the best possible way. So in the transactional environment, we are talking role-based storage for MariaDB or MySQL is typical InnoDB database, or even MyISO or MyRocks. We are using indexes a lot, because indexes can improve the performance, and we have solutions to grant and to give high availability to our application based on clustering, replication, and so forth. On the other side, when we wanted to have more performance when it comes to run analytical queries, we want something that is designed for that. So that's why Columnar storage or Columnar databases became popular as probably the second wave of data warehousing. No indexes there, because indexes are actually not performing well the more the data set grows. So the more data we have, and the less the B-tree approach of indexes starts to perform. So we need something that is not having indexes, not because indexes are bad, but because when you're talking huge amount of data, that's where the indexes become an issue more than a support for the performance of the query. And due to the size of the data set, due to the growth of the data, due to the fact that we are storing more and more information, we want to have high availability, but also distributed environment. So that's where we have seen solution designed to be distributed. What has been, I'm simplifying a little bit, but the approach has been data warehouses from one side, which were different. For some of the database administrators that were used at the typical relational environment, they were hard to use, they required new skills, they required a learning curve that was causing anyway some impact in the companies. Most of them are NoSQL based. Think about Hadoop, Cassandra, they have no SQL interface, or they had no SQL interface at the beginning. So even the existing application or the existing SQL approach that has been there for many years for the transactional environment was not that helpful. So a demand of better way to query this database, but with different approaches. Even finding people able to work with this new environment. If you talk database, more or less anyone can run an SQL query, but when you take an SQL expert in front an NoSQL query, it might not be that comfortable. So also new skills needed, at least at the beginning. Now it's not that true anymore. Even from the physical point of view, sometimes we talk, or often we talk to our customers, and when we ask them, transactional environment, typical ACID, and when we ask them, do you also have some analytical solution or project in your company? The answer is normally yes. And after this yes we hear, oh, we don't even know them. We know they are somewhere, but we don't know them. We have no relationship with the guys of the analytical BI. And this means that this wall, this cultural wall, sometimes it's even a physical wall. They live in different buildings sometimes. They don't talk to each other. Sometimes these guys just know that need to extract some data every now and then, and the interval is normally defined by between someone from one side and someone else, and they need to move data in this direction, so the BI team or the data science team can work on it. But there is a time interval, so no synchronization, and some data can also get back from here to there, so some of the results of the BI can get back, but still it's a process which is not normally online. Think about something more related to e-commerce, something that we do. MySQL and MariaDB have been the backbone of many of the internet-based applications. The typical LAMP stack and the typical solution that is selling something. Most of the time services. Think about Booking, selling rooms, or BlaBlaCar, selling car sharing, or Amazon. We all buy from Amazon, right? So the idea of having something a little bit more close to the existing transactional application, which, I mean, if I buy something on an e-commerce website, it's a typical transactional activity. I browse through data, I retrieve data from the database, I work on those ranges. I want this kind of books, or this kind of shoes, or this kind of shoes. I want this kind of things that are in the specific range of research, and I want to try to find which is the best for me. But this idea of the best for me comes from my feeling, but also from recommendations. So someone behind the scenes wants to improve their business and increase my will to buy, which is not that difficult in my case, but sometimes they want to increase the profits, so to push people to buy more. So if I buy a pair of shoes, they also probably want me to buy another pair, but maybe a pair of socks, and why not buying a purse or a new bag or something like that. And this is something that is done through analytical queries. In the past, this was probably done within the same transactional database, but the more products you sell, the more users you sell, the more you want to be effective on this process, the more you want to have something ad hoc. So the idea is to have something that tells me that everybody who bought this or put this in the basket also bought this, and I can probably buy more and they get more profits. So the idea of analytical is not just to understand the famous W, where, what, why, and have a predictive analysis or why analysis to try to understand why something happened and try to predict what is going to happen, but also to push the result of these queries in terms of profits. Something that is more related to now. Think about sharing. Car sharing is something that's really related to now. This car is going to be used by you and someone else now. Okay, this is transactional. But then the idea on where is much more profitable for the company to position cars when we're talking about car sharing so they can be used is something that can be retrieved based on analytical, but also based on the fact that we know how people move in real time. So two different workloads within the same application, within the same solution, most of the time. This degree of separation that we want to solve, to have something that is able to provide us something more related to our real-time business, something that is able to provide information to the existing transactional activity. So that's where we have seen ColumnStore, column-based databases are helping. Having the ability to put together the transactional workload and the analytical workload within the same database infrastructure without having to interact with BI teams, sometimes, as I said, outside the transactional database administrator environment, is something that provides value. MariaDB ColumnStore comes as a storage engine for MariaDB. So this means that we have a single front end, which is MariaDB. I don't know how many of you use MariaDB, I know a few, but the idea is that MariaDB is providing an architecture that is supporting pluggable engines. So this means that we can have different or way to deal with data, engines for data, that can perform in different ways based on the different workloads. So from one side, we have the InnoDB storage engine, which is fully transactional, CID, designed for being reliable and fully transactional, as I said. On the other side, we need something more designed for that, which is a columnar engine called MariaDB ColumnStore. How many of you know about columnar engine or columnar databases? Have you ever used some? So, if you use something, I will go quickly. We're all familiar with the idea of the row-oriented database, right? The typical table, rows, columns, where we are basically storing, like in a nice Excel sheet, all our data in rows. The idea is that when we have to run a query like that one, a simple one, we are normally seeking for one field, which is the fname, with a where clause, just touching basically 2 columns only. That's a simple one, but guess if this table is 500-600 columns wide, you're basically going through the table, through indexes, to go through the state column and find where the where clause is satisfied. And while we do this, we are actually retrieving a huge amount of data that we don't need, because we are just looking for the fname field. And we store in memory a huge amount of data that is just rubbish for us. We are not really needing that. But it's causing a lot of work in terms of CPU, scanning, loading, interacting. The idea of columnar engines is to have something that instead of being arranged by rows and being stored in a single file, is actually stored in as many files as the number of columns are. So we have 500 of files, each and every one of them is storing the data within the same column. So in this specific case, when we are selecting from people and we want to retrieve fname where the state is new and y, we just go through the column state, which is a tiny little file compared to the table size of the full row-based table. And for every occurrence of the ny, that's the close, we just retrieve the data. So very tiny, very compact, no need of indexes because every single column is actually an index itself. What's not good when we work with columnar engines? We can't work with columnar-based engines the same way we work with the transactional, the row-based, because it's whenever we hit the disk, whenever we work with the disk I/O, that's where we lose time. Just to make it simple, right? We make things more complicated. So whenever we have to insert a single row in a transactional engine, we basically open the file, insert the row, close the file. If you want to do something like that with a columnar engine, we are actually required to open hundreds of files, write a single piece of data, and close hundreds of files, which is not really effective. So the columnar-based databases are designed for bulk load of data. So we want to add huge amount of data, hundreds of rows, thousands of rows at the same time, so we can optimize this open-close activity on the disk. What is instead good at? Single updating rows when it comes to update a single column is then much more effective if done on a columnar engine. Because in this case, we are actually not really effective when we have to update all the rows of that table because we are touching every single row. And so we are updating a lot of data just for a single column. In the columnar engine, the column update or even the column insert is much easier. You don't have to interact with the table structure. We just add another column, which is very convenient when it comes to do analytics. So we are just adding columns to an existing set of files without having to change the structure of the file itself. Same thing for delete, the same thing we said for insert is there for the delete, just not recommended. Even if you have to delete a single row, and sometimes you have to delete a single row from a columnar engine, it's much more convenient to flag this row in a way which means that this is not to be considered. It has to be much more efficient than deleting the full row because it's really expensive in terms of time. Changing the structure that I told a little bit about. What's the beauty of the ColumnStore engine? As I said, the single front end. So we are talking SQL here. We are talking the ability to have an engine ad hoc for analytical without having to change the application, to change the queries that we've been running on the transactional environment. We are just use the same queries. We can use the same queries, or we can have another application. But the impact of this columnar contribution to the application workload is actually, I would say, transparent. You can just add a new table to your tables in your database, to your schema, just telling with a simple SQL command, create table / engine equal ColumnStore, that that table is going to be supported by a columnar engine database, storage engine. So we don't have those SQL-like queries that we have seen coming to the NoSQL databases where at a certain point some SQL support was required indeed. It's full SQL, fully SQL. It's very scalable. The idea of ColumnStore is to have the ability to run on commodity hardware, so not having also the hardware impact, something I haven't mentioned before. is that with data warehousing, with this new approach to the data management, a lot of investment was also required in terms of hardware. Some of the solutions could only scale up. They were not designed to scale up. So you had to have those consideration also when it came to consider the cost of the investment. The idea of the analytical support that comes from ColumnStore is to have commodity hardware that you can easily scale out, adding modules that can either increase the performance from the user point of view. You have many users, you can add more front ends, but also in terms of performance, you will be able to add more performance modules, as we will see in a second, to increase the performance of the query execution. Here is how, roughly, the architecture is designed. So if you go from the top to bottom, we have the application layer on top. That can be business intelligence tools, Tableau, any kind of tool that you are familiar with. Zeppelin is becoming more and more popular in the open source world, or your custom application. Then there is the MariaDB front end. Those are called the user modules, and they're actually in charge of dealing with the query parsing and the query planning. And then we have the distributed engine, the performance modules, which are actually in charge to get from the users modules the query plan execution. Each and every of the performance modules will be in charge of a portion of the query execution. And the common layer, the common ground, is the data storage, which is normally a shared storage. It can be any of the formats that you can see. It can be a SAN, it can be, some of our customers use Amazon S3 as well. It can be a local storage distributed with. The high availability of the data is actually supported by the storage itself. So those modules don't store any data. They are just in charge of dealing with data, managing data, and retrieving information. And once the performance module work with the data sets that they were required to work with, the portion of data are returned to the user module, which is in charge of assembling the result set and returning this to the client. So the idea is that we have two levels of scalability, as I said. There are best practices when it comes to have a proper setup. There is a little bit of high availability also when it comes to have user modules. In theory, you can start working with a simple user module front end and a performance module as a backend. There is no scalability at that point, not even parallel processing. So the idea of the parallelism that we have with the performance module that you see there is actually a little bit compressed, I would say. But that's an easy way to start. We have customers that gained 100 times performance just having a single model and performance module, based on the fact that the columnar management was good enough for them to increase the performance compared to the B3 indexes and the transactional approach. As I said, shares nothing. So each performance module is actually attached to the storage in a different way, depending on the storage solution. And the nice thing that ColumnStore can do is that that portion, we will see how they work later, can be easily redistributed whether we add a new module or we remove a module. So there is scalability in the performance, whether we add more modules or we reduce modules. The data set is actually shuffling to some extent in order to be redistributed among the existing and active performance module without having to manage those. It's actually managed by the console.
So that automatically, if you add more modules, and if you have failure, also redistribute the data as well.
That's done by console. So we'll see a little bit later when we go through data that the data is actually split in several blocks or extensions, and those are actually attributed to every single module. If one of those disappear, those are actually reshuffled. Okay, so what do we need, roughly? As a commodity hardware, there is a little bit of difference between the user models, which are actually servers, and physical servers or virtual servers, and the performance module, because those are in charge of different tasks. The performance module can actually be very tiny. They are basically just workers, runners. They just go to the disk and retrieve data. The component who is doing the most is actually the user model, which is in charge of parsing the query, creating the best possible query plan, and then assembling together all the bits and pieces that come from the performance model. So we need a lot of RAM. We need to have the ability to be fast in putting together the results, and of course, the more you give, the better it is. But the idea is that we don't need much in the performance modules. So it's easy to scale and increase the performance, adding modules which can be really non-expensive. We are moving now to have a nice solution in cloud environments, which is something that customers already do, but also to be able to deploy these components, the performance model, in containers, and so being able to expand and shrink depending on the workloads. So we can, and this can be easily done based on the fact that data can rearrange automatically. So it's not just the idea to have, the more I have, the better it is. It's much more convenient to really have what I need when I need it. So we said a little, I explained a little bit what why a columnar-oriented engine can provide a better experience when it comes to performance. But what ColumnStore does on top of that is to provide a nice way to partition data, not only through columns, but also horizontally. So ColumnStore has a way to organize data based on horizontal partitioning, which means that whenever I load or byte load data into ColumnStore, these chunks of data are stored in blocks of 8 million rows each. Every time I fill this block, this portion, this partition, a metadata file is created attached to that partition. This metadata file, simplifying a little bit, is storing a simple but very important information: the minimum and the maximum value included in every column. The metadata file is actually having the minimum and maximum value for each column of that portion, which means that whenever we have to, this is the way those partitions are, but we will see this a little bit later. So whenever we do this, and whenever we have this set of data, and we have to run a query like that one that you see there, the performance module are actually going through files and checking the metadata files. They are not actually going through the data set itself. They go through the metadata files and check, okay, my workloads, I want ship date between those two dates. I go through every chunk and I check if my workload is satisfied by that extent. So in this particular extent, what I see here is that in this first extent, the column ship date is actually storing values between these two values. In the second extent, the ship date column is storing data included between these two values, and so is in the extent number 3. The execution of the query is actually going through this and skipping 8 million rows at a time when it's scanning that column. So this means that I have the columnar approach, no indexes, so I can go through, even if it's a full table scan at the end of the day, but I can skip 8 million rows at a time whenever the condition is not included in that. Of course, there is a little bit of performance increase when I talk about non-known queries. If you know your queries, you can gain a little improvement in your performance because you can bulk load data, pre-order bulk load data. So if you're running queries based on date most of the time, if you bulk load your data by date, you're actually skipping a huge amount of chunks because you just know exactly that every date is just in one specific block. So there is a little bit of tricks that you can play on that. But this is the idea, columnar and horizontal partition. Back to what I was saying, when it comes to distribute this extent, sorry, I switched the order, but when it comes to distribute this extent, so these blocks of 8 million rows, through the partition, through the performance volume, I actually do something like this, 1, 2, 3, 4, 5, 6, 7, 8. Whenever I reduce, they are just being reshuffled, and every block is actually absolutely clear where it's going to be. So the user module and the performance module have a clear idea of where the block they need to work on.
Can you configure the redundancy levels for each table, or how's that done? So if you want to have like 2 copies or 3 copies, or depending on if you're having separate, separate storage and separate.
You can do that, but it's not ColumnStore doing that.
But I thought the whole point of what you said, you can actually have share nothing, so you can have multiple performance modules.
But you don't have multiple copies of the same extent.
You don't. So if you lose it, if you don't have multiple copies and you lose one of them, then you lose your data.
You lose your portion, yeah.
So you can't have you don't have redundancy to cover that. You have to make the storage redundant.
Yes.
Okay, but then it's not shared nothing because then you're using shared storage or something, which is extra more cost rather than allowing this.
True, you're right. Sure, the high availability here is supported by the storage. So the high availability of the modules is just in performance, not in the data.
Because otherwise some of our systems provide the ability to have the storage made, or the storage part written doubly to provide that redundancy, but that's not provided in the Columnstore.
No. Okay. So when it comes to that bulk load data, then we need to consider this idea of bulk loading. So whenever we add data, we are either using an existing not completed extent, so we fill it, or we start a new one. But this idea is that this is the way data are loaded. So we've seen the example in the query, but this is way when I bulk load CSV data are quite common. Those are the values. And so whenever we load, those are the 2 values that will be stored in the metadata file. How can I insert data? Of course, it's clear that it's not easy to or not convenient to perform single inserts. But still, it's doable. It depends on the set of data that are the result of that. CP import is actually the ETL tool that comes together with ColumnStore. It can basically import data from any format, more or less. Load data in file is still supported, just because it's the compatibility of MariaDB or MySQL approach in terms of SQL is still there. It's not very convenient. Why? Because CP import can work either from the, let's say, top down, so going from the user model down to the data on disk. But CP import can work directly on the status storage. So it's able to read data from the import file and bulk load directly on storage without having to go through the whole processing and all the way down to the data set, which is much more convenient. It's very, very fast because it's able to do create extent, write extent, it's aware of the existing extent on the disk and arrange them properly. It's also important to say that it's not really that important that we're using or importing a huge amount of data. So the idea of bulk loading is not that you need to have billion of rows to run an import. We have a couple of customers that are running IoT solutions, and they're actually storing data into the transactional database for some reason. They need to clean them and purge them and remove some data, but they need to or add more data. But from there, they push data down to ColumnStore. And they do this to micro batches, which are run every 10 seconds. So they import data, they clean them up, and then every 10 seconds they read from InnoDB and push data into ColumnStore. They clean up the InnoDB at the end because they don't store data into the transactional database. It's just to cache, more or less. Every analysis is done on the database. So not, okay, a huge workload every night. It can be even 10 seconds or 1 minute, whatever. But the idea is not to have to do single insert. There is a nice concept of watermark in ColumnStore. So if you are bulk loading data, and we are talking huge amount of rows or millions of rows, you can still work in. You don't have to stop your activity on ColumnStore because the CP importer is able to draw a watermark line on your data and insert data from that point on, and the ColumnStore itself is not touching or considering this data below the watermark. So it's something that you can run without having to worry about the consistency of your data. Delete is something that I also touched when I was talking update. Consider if it's worth deleting the single row. It's much more convenient if you know exactly the way you're loading data. If you're considering data through data ranges, or to drop complete partitions or portions. This is something that is much more convenient because you're really destroy an extent and then able to recreate an extent. But it's more in the best practices. We're working on this support for APIs because we want to be compatible with other tools that have already been prepared. This is more for the CDC support that we have with MaxScale, with MariaDB MaxScale. MaxScale can also play the role of the change data capture tool. So as part of the solution, you can bulk load your data with your ETL tool, use the CP import. But another possibility is to have MaxScale reading from the bin logs of MariaDB, InnoDB, Binlogs, and pushing data into ColumnStore. MaxScale CDC is also able to push data to Kafka or to other recipients. It's not just for ColumnStore. So it can even be that, back to that slide, we can provide data into ColumnStore, but also into other data warehouses or other solutions based on the same MariaDB, InnoDB solution. A few comments when it comes to design data. That's, of course, for those who have never been into the analytical workload or the analytical environment, just want to gain a little bit more performance on the existing transactional data. Of course, you need to change the schema. A little bit of manual activity is required when you move data from a typical transactional environment into a columnar-based environment. It's important to design data in a way that they perform well when it comes to columns. So if you have complex field, it's more convenient to split them. Consider phone numbers, block numbers. If you can split them, it's much more convenient to have better queries because you're working on columns instead of having a complex field that is not easy to go through. It's very important to be conservative when it comes to play with fields. The more compact we have, the columns are, the better it performs. Yes. Some of these things are something that we've been through already during the conversation. Just a recommendation: avoid low data in file. Not just because it's not working well, it's just not the best performant way to import data. But the reason why it's still there is, as I said, to guarantee that we can be compatible with existing tools or existing solutions, so you can carry on loading data instead of your transactional table into ColumnStore without a change. Some of our customers don't even have access to applications sometimes, or they're not allowed to change. Okay, thank you guys. Thank you very much.